So if you're going to do this from home, you need to grab this file from here and take it home, or set this up on your own at home. All right. This is kind of, it short circuits the whole thing, makes it a little bit faster for you. So we're going to launch a VMware Workstation. If you don't have VMware Workstation at home, you're more than welcome to download it for free from the DreamSpark store. You can get it for free up there. I'm going to click on Remind Me Later. At home, it's not going to make a difference if you use 12, 13, or 15, or what is it, 12, 14, or 15. It doesn't really matter. You can download whatever you want. You can make this compatible with it at home. All right? There is one thing that you need to do here in this classroom. You need to come up to the top, and you need to go to Edit, Preferences. So this is the only place that you need to do this. At home, you don't need to worry about this. You can change it to put it wherever you want, but you're going to click on Default Location for My Virtual Machines, and you're going to browse, and you're going to select the SSD drive, and you're going to make a new folder called your username. Again, some of you have been through this with me before, so it should feel fairly familiar. It'll speed back up. There's probably several people doing it. That's not bad. That's an 8 gig. That's an 8 gig file. That's an 8 gig file that's coming down as the other ones close up. Yeah, an 8 gig file. I mean, look at that. You got like 45 seconds remaining. That's not bad. We actually have a 3 gig link back to the NAS. That's where it's stored. When I have like the whole class hit it, it takes like, that whole thing takes like, by the time we're done setting up, everybody's is downloaded. So that's why I start that and then come back to it. Your username. Make it your username. Now remember, this is the only place that you have to do this. The reason is you don't have write permissions on all of the other areas on your computer. So we'll make sure you have a write permission here. The default is your H drive. The H drive has like 200 megs. It's not really good. Okay. So after we've done that, what we're going to do is we're going to find that Windows 7 Lab 2. You're going to go inside of it, and you're going to double click on the Windows 7 Lab, not the disk 1, that's the disk file. The Windows 7 Lab, double click on that, and it's going to import it for us. See how this pops up and it says, oh, do you want to import that? Well, as a matter of fact, I do. So when I click on import, it's going to say it did not pass the OVF specification. Just click retry, not refry. Retry, and it'll be fine. It'll be okay. It'll boot up. It'll be fine. That's going to take a few minutes, and as it takes a few minutes, I do want to talk about what's going on here. No, you shouldn't need to rename it. I mean, you probably can, but you shouldn't need to. You should just be able to import it. It'll be fine. Okay. So we're not going to get all of this done today, but we're definitely going to get a good start. All right? Little Rose is like, what happened? Well, let's have a look. So we'll hit OK. Let's double check this. Preference. Oh, you didn't change that. You must have started it and then you didn't OK. You didn't say OK. So we need to say SSD. Did you make one there? Nope. So make new folder. Make it your username. Where did it go? Is that it?
Wait, I didn't finish.
Okay. Whee! you doing? You're typing something. You're hitting something. Try it again. Slow down. There you go. Hit OK. Just let that. OK. There we go. Now try it again. We should be fine. You need to hit OK, and now double click on it again. All right. Neighbors help neighbors. What's up? What's that? Yeah, you need to go to pre-build OSs, and then VMware here, and then this one. You're going to drag that to the SSD drive. There you go. Sound good? Okay, so neighbors continue to help neighbors while we're waiting on this stuff to kind of get set up. So I want to give you some terminology. Some of y'all are going to know this because you've done and experimented with this stuff before. Some of you are not. But all of you are going to be held responsible for it on the final exam. So we're talking about virtualization. Virtualization is not emulation. Can somebody tell me what emulation is? Tell me what emulation is. Anybody own an emulator at home? Really? There's nobody out there that's downloaded an N64 emulator, Commodore 64 emulator, Super NES? So what is the emulator part then? Yep. The old hardware, whatever it is, the N64, the Super NES, so on and so forth, that hardware is emulated with software, okay? So when you plug in the cartridge, in this case the ROM, it'll start playing back as if it's playing back on the original hardware. So anytime you hear somebody say, well, it's emulated, you got to think it's hardware that is run as software, okay? Virtualization is completely different. In a virtualized environment, in our host computer, we have our CPU, and we have our RAM, and we have our GPU, and I'm going to say, etc. Typically, an operating system, back before virtualization came around, it was one operating system per host machine. There was one direct link to the CPU, the RAM, the GPU, the hard drive, so on and so forth. In a virtualized environment, we're capable of allowing our host, and that is the physical machine, to be able to run multiple guests. And the guest, via the hypervisor, enables us to be able to jack into the CPU, not just the host, but all of the guests. And they can tap right into the RAM as well. And they can tap on some hypervisors right into the GPU capabilities, directly into it. And this is a hardware feature of the CPU, RAM, GPU, etc. This is a built-in feature. And where it came from, I'll slow down. it's a hardware feature of the CPU, the RAM, the GPU, and all the other hardware that's built on it. Some hardware is more sophisticated than others. Some hardware can enable you to tap directly into like the system buses and stuff. Like in an enterprise level, you can tap straight into a hard drive instead of actually having an image of a hard drive, which is pretty cool stuff. You tap right into those different buses. So where all this stemmed from was the resource utilization on computers. System administrators were noticing that their systems were hovering at like 15 to 20% or less utilization. If I got 100 of these devices, computers, servers, sitting around and always idling at 10 to 15% or less, that's a lot of wasted resource. It's a lot of wasted power for powering the servers. It's a lot of wasted power keeping the area cool. That's a lot of wasted man hours when it comes to repairs, because now I have 100 devices I have to worry about repairing, right? It's a lot of wasted resources in connecting all network cables. The list just goes on and on. So Intel acknowledged this. Now, we've been able to do it for a while, but it just takes a while for things to be developed. So Intel and AMD, they acknowledged that this was a problem, and Intel came up with something called VT, and AMD just came up with V. Those were the original virtualization hooks built into the CPUs to allow multiple guests to tap in to the resource. Now there's a whole bunch of additional virtualization technologies that gives that more fine granular control of what you're actually accessing under the hood. All right? Question?
Is the 15 to 20% specifically for CPU, or is it involve like all of the hardware resources?
We could just, however you want to view it, just kind of more of a number. It could be CPU utilization, it could be CPU and hard drive, you know, whatever. The point is, it was a really, really low utilization. So now, with VT, we could take using these numbers, 4 physical devices, and put them onto one virtualized environment. So now I got to introduce to you, I've mentioned host and guest. We have a host machine. The host machine is always the physical machine. So that right in front of you, that is your host machine. And then the guest machines run through the hypervisor. So I'll call it G1, G2, G3, G4, G5, G6. So the guest machines access a hypervisor. That's a technical word. This hypervisor is the virtualization piece of middleware. There's 2 types, and we don't have to get too in the weeds here, but there's 2 types of hypervisors. There's a hypervisor stage 1 and a hypervisor stage 2. We're going to use a hypervisor stage 2. That is a hypervisor running in a guest operating system. Okay? We got to have an operating system. Hypervisor 1 is what's referred to as bare metal hypervisors. Now, it's still a really teeny tiny kernel that is installed, but its footprint is very tiny. I'm talking like kilobytes big versus the footprint that you have running for Windows 10 and servers is megabytes big, and sometimes it is gigabytes big, right? Why are we going to use that if everything on this is going to be running in virtualization, right? Now, out of all of this, some of the different hypervisors that we have are VMware. We also have Hyper-V. So VMware is VMware's own product. Hyper-V is it's a Microsoft product. All right? And then there's a lot of other ones out there. Oracle is developing its own. There's another free one out there. These, by the way, cost money. Out of VirtualBox, which used to be 100% freely developed, Oracle bought it, and they're developing a commercial hypervisor for the Oracle stuff. But you can download VirtualBox for free as well. All of these are great products. The granddaddy of them all is VMware. All right? Now, tying some of this stuff together just a little bit for you. It gives us a safe environment to experiment. What can we experiment with now? I know my security people have used hypervisors a lot. What are some of the things you've done in this safe environment with VMware? All your forensic stuff, right? You've loaded up Kali, you've analyzed hard drives, you've attacked things, you've done penetration testing. Who else has used VMware or something similar? What have you used it for, Coy? Okay. Mitchell, what'd you use it for? Okay. Anybody ever played with a Linux distro? Now you can play with a Linux distro. Everybody's aware that there is a database filled with viruses. Did you know that? You can go out on the web. There's a whole database out there that enables you to download viruses and unleash them and see what happens. Probably you don't want to do it on your main machine, so you can use this environment to be able to experiment. That's how we use them. How does an enterprise use them? How does an enterprise use virtualized environments? You ever thought about it, Brandon? Absolutely. So, for example, in Frostburg's environment, and most of the other environments that you're going to encounter, we have a data center. We used to just call it a server room. Now we call it a data center. Whatever. Yeah. We have this up there, and we used to have about 120 physical servers inside of there. At one point, that's how many there were. Now there's 5. There's 5 big, massive servers. All of the other physical servers that used to be in there are on those 5. We use a very sophisticated, high-level VMware solution. It's called ESXi, along with Hypersphere, right? That enables us to be able to manage that environment. Now, we have that duplicated in 2 other places for backup and redundancy and disaster recovery. But all of those run at about 80% all the time. They have multiple cores. They have like 256 gigs of RAM. They got a huge solid-state SAN, the whole 9 yards. So that's one way. Now let me tie this idea to cloud computing for you. We all know that who invented pretty much cloud computing? Who really made it blow up? Everybody's like, I don't know. I don't want to say anything. Who is the leader in cloud computing? Amazon. Amazon is. Point blank, it's Amazon. And this is what happened with Amazon. How did they get their start? Before they were a cloud computer leader, very start was books. Then they grew into what? Stuff. We all buy stuff. Well, when does Amazon or any retailer in America sell the most stuff? No, they made their own Black Friday called Cyber Monday, right? Now, I don't know that Amazon did it, but they all came together and said, let's do Cyber Monday. But the point is, they start around that Friday after Thanksgiving, and it runs right up until a day or so before Christmas, right? That is when they sell. Oh, it's ridiculous. Like 70% of their sales are generated, maybe not for Amazon anymore, but it used to be. That's when most retailers make their money. 70% of their money came from that point, right? If you're an online retailer, what don't you not want happening? To what? Your site going down. You know, think about it. Amazon has like something ridiculous, like 10,000 simultaneous sign-ins per second. They claim that it's tens of thousands of sales per second on like Cyber Monday and some of these other days. That means that if you're down for even 1 second, you're theoretically missing 10,000 sales. That equates into millions of dollars in lost revenue in a very short amount of time. So, the first time that happened, Amazon said, that ain't happening again. So they went out and bought a whole bunch of other servers, propped them up. Cyber Monday rolls around next time, guess what happens? It still slows down. So they go out, they buy more equipment. For that very month, those couple of days, guess what happens? It still crashes. They go out, they buy more hardware, specifically for those months. Finally, it stabilizes. Now, what do they do with all this other hardware? The other 11 months out of the year. What if I rented out my resources? My processing power for people that want to work on big data stuff, all my spare hard drive space for people that want to store stuff. Maybe I'll move into a TensorFlow application for those people that want to do AI. And cloud computing was born, right? It's a very practical, what do we do with all this stuff? Like, it's paid for itself, but I'm pretty sure I can make more money off of it, damn it. And they did, right? And then everybody else kind of followed suit. And now everybody's still playing catch up, including Google and Microsoft and all the other guys that are out there in this space. So helping you connect together what we're doing here in the classroom and how we use virtualization with how it's going to be used when you get out, I'm hoping I'm kind of closing that loop a little bit for you. All right? Because you're going to be out there. You're going to be out using it. So let's have a look. I think everybody's stuff is kind of imported. Before you click Start, I want to show you a couple of things. Most people's stuff, it's imported. If it's not, that's okay. It will be in just a few minutes. So virtualization gives us some really wicked cool tools. All right? For example, we can take state snapshots of our hard drive. State snapshots enable us to quickly go back to a period before we installed something or made changes. All right? This is kind of like, who's an Apple person in here? HFS Plus enables us to be able to use Time Machine to go back in time. It's a very similar thing. Time Machine on Apple's takes a differential every 12 or 24 hours of the state of the machine now and the state of the machine now. And if you want to go back in time because you accidentally deleted something, you pull up Time Machine, you go back in time, oh, there it is, I want that, and poof, it's restored in a matter of seconds. It's the same principle as what's going on here. So let me show you how to take a snapshot. We simply right-click on this guy, and we say Snapshot, and we say Take a Snapshot. And we say Before Launch. And boom, snapshot is now taken. Now another thing that we're capable of doing is cloning. We can actually make multiple clones of this machine. So we could say, well, I want a couple machines. So I'm going to right click and I'm going to say Manage, and then I'm going to go to Clone. And with Clone, it's going to walk me through a wizard. I cannot speak today. Not a lizard, a wizard. It's going to take me through a wizard asking me, what do you want to do? Well, I want the current state of the machine or an existing snapshot of something else. I'll do current state. Do I want to do a linked clone or a full clone? A linked clone takes the differential of the base. A full clone completely replicates it. So if I completely replicate it and it was originally a 20 gigabyte image, now I got two 20 gigabyte images. If I do a linked, it's much, much smaller. It's the 20 plus whatever the differential is between the base and the linked clone. All right? So I could do a linked clone, and then I can come in, rename it, so on and so forth, and now I have two machines. And then the last thing that I need to show you before we launch this is, let's say I need more resources. The only limitation of virtualization is your physical resources. If I need more resources and I have a CPU, anybody got one of those fancy AMD Threadrippers? Really? AMD has a Threadripper out there. It's got 16 cores, 32 process, or I'm sorry, 16 cores, 32 threads. That's pretty cool. Initially, I just dedicate 2 cores to it. That's not enough to process my data. I can go in and I can up my virtual machine to now take advantage of 8 cores or 12 cores or whatever. And the same thing with my memory. I can come in here and I can simulate a machine that has more than my physical machine, but these particular machines actually have 32 gigs. You can see it right there. So I could actually go up and put 16 gigs in here with no problems, and now I have more resources from the physical machine being utilized inside of my guest machine. So all of these are in your power to be able to toy and play with to get the resources you need. Brandon.
How exactly is it, or are you able to like specify like more than your host machine has?
You can, but what will start happening is if it actually exceeds that, it starts rating stuff out to a hard drive or a solid state drive as memory, and then everything just plummets. The idea with the 64 gigs, like you say, I want to put 64 gigs in it, is you're in a testing environment, and you're going to actually put that onto a machine that actually has 64 gig capability. Because that's really what we do is we test it on our desktop, and then we deploy it out to our vSphere environment. And our vSphere environment probably has 512 gigs of RAM or something ridiculous. Does that make sense? You can do the same thing with processors. You can actually simulate more processors than you have if you want, but they're not really going to do you any good. So whenever you're ready, you can go ahead and start it up, and it's going to go through what's called a sysprep script, and this is going to generate all the basic identifiers for our environment. So where we're going to be at when we come back next Monday is we're going to start installing the XAMPP environment. And this is a LAMP environment. LAMP, Linux, Apache, MySQL, and PHP. A word of caution. In a production environment, so if you're ever charged with doing this read out there, do not use XAMPP or any other pre-packaged environment. And it tells you not to do that. It will tell you, do not do this in the real world, because they cut some corners when it comes to security, right? They build them to default passwords. They reduce the security in some areas, and they don't want you putting that into production environment, because then you're going to end up getting hacked, all right? But in our environment, we are a development environment, and I just want you to get up and running and playing with some development. We're going to use XAMPP, all right? So those of you that want to go home and start playing with this more, you can do that. On Monday when we come back, we're going to go through setting up XAMPP. We're going to configure a firewall so we can look at each other's, we're going to make a basic website site so we can see each other's stuff. Maybe we'll get a little database set up, and maybe we'll walk through some other stuff, and then I'll give you all of my code so you can start dissecting it and playing with it on your own to set up this really small database that stores this. I can't remember which one I have, but it will either store songs and track names or like a name and stuff like that. It's pretty simple. The idea is, though, I want you to get familiar with this LAMP architecture. It's going to get you exposure to HTML. It's going to get you exposure to PHP. It's going to get you exposure to MySQL and basic SQL statements. Okay? This is the level that I need you to be at for your project. That's why I'm taking this time now to show you where you need to get. When you come in, you don't have to go through everything I just did. You need to say, here's what you need to know, and let's do a demo, right? So the demo is all set up and ready to go on your computer, either in here or on your laptop or whatever. Okay? Question? Yeah, I keep saying Monday. I'm going to be at a conference on Friday. What's that? Well, if you really want to come to class and continue working on this, that would be a good thing. I am going to put a little bit of work up for you to do. I want you to do that Excel thing that I wanted to do a long time ago. It's a different one, though. I got one that's only like 2 hours, 2.5 hours. So I'm going to ask you to do that. I have the exam slated to grade tomorrow. I got through a whopping 1 question yesterday. So I have that slated to be graded tomorrow. So hopefully I'll get that done before the weekend at the very latest, because I like to get those turned around for you all, so you know. Okay? Here's another really neat thing. You know how Hibernate doesn't always work really well on your computers? Well, you can just click pause here, and boom, it's paused. The state is completely paused. And you can come back in and click on play again, and it'll pick up. Even in the middle of installation, you can click on pause, and it'll save it exactly where it's at. All right? But if you want, you can finish this stuff off, because you got a couple minutes there. I was thinking Wednesday of next week. I'm just messing with you, Brandon. Those are due. Those are due like after Thanksgiving is when I have those. That's when I'm. Let me see. 1, 2, 3, 4, 5, 6, 7, 8, 9. Probably going to have to do 3 per day at 15 minutes each with turnaround. So 1, 2, 3, 4, 5, 6 days. So that'll give us 6 days right after Thanksgiving. Maybe one more if we need. Oh, by the way, I don't play the whole, you just turn it in whenever. Everybody will have to be done when you come back from Thanksgiving. Presentation done. You can work on your demo, but you're going to turn your presentation in. And then you can present what you turned in. Because I find it unfair if one person goes and then somebody's like, oh, well, I'll go back and fix my presentation. So I don't care about the demo so much, but okay. All right. Hey, what's up, Paulie? VMware? Yep.
Yeah. I used it like 2 years ago. And I think it was like a 90-day license. It doesn't restart.
This will give you a 365-day license. Actually, it's more than that. It's like they give you like 300 days or something.
Just a semester. So that's just why.
If you got it off of our DreamSpark, it's always been a year.
Oh, okay.
You get a year license.
Okay.
So what you want to do is you want to time it out so that you can renew that license just before you graduate.
Yeah.
So you get one more year out of it.
Yeah. There we go.
Sound good? All right.
I just remember that thing. I used it like fall 2016, like my sophomore year. So
Yeah.
it's been a little while.
Cool. All right.
Okay. Since I was late, I kind of have no idea what we're doing for this project. So like we have to pick a software or something. And
You got a whole bunch of classmates that'll help you out with this, Jesse. Spencer is the go-to man.
he's right there. He's in my other class. So.
We just have to pick some sort of technology and then
Whoa. Some sort of technology that relates to.
Information system.
Yeah.
Does it have to be on like an enterprise level? Or
Don't ask me, ask him.
I would say yes.
I would say he's correct.
I want this policy.
I'm sorry? I shouldn't have, but I did mark you late. You were really late. If you have what? Yeah, get rid of it, man. Yeah, get rid of it.
So good.
I know. That's why I'm giving it away, Spencer. You eat as much as you want.
Quick food sounds good. As long as you're burning through it. It's a candy shop in town.
It will catch up with you one day, my friend. Yeah, you can do that.